Welcome to ArtX video series. This video is on Art Toolpaths. This is first in a three-part session. We have in front of us the Celtic blend example. It is also set below the axis here, the Z-axis, prepared for machining. What we're going to do in this video is show you how to make a custom tool. When you're doing art toolpaths, most art surfaces have high detail. To get high detail, oftentimes one has to use a taper or V cutter to achieve a very small tip, but with strength. If you used a 32nd ball end mill, it would be very brittle. But if you use a V cutter with like a 20 thousandths ball end, you get strength as well as detail. So we will teach you how to make a custom tool. So we're all ready to go here. We'll go up and pick the icon for Art Toolpaths. Take the default, and that will bring us into our toolpath page. Now notice I have just 3 tools here. If I select the tool library, the standard library comes with many tools, but oftentimes we only use 3 or 4 when we're doing specialized things like coinage or jewelry or art applications. So what we'd really like to do is have some custom tools that we normally use in our own library. So the way we do that, and I'll delete this tool, and then we're going to click into the field and say create new tool, taper mill, and let's set this one up for a nice art tool. So I'm going to say my radius for the bottom of my tool will be 20 thousandths or 0.020. My taper angle will be 15 degrees. I want a full radius on the bottom. I want it capable of both roughing and finishing. My flute length will be 20 thousandths, 200 thousandths, 0.2, and my shoulder will be 0.25. Now we can see here that the shank is a little out of proportion. For a tool that size, usually the shank is 0.125 or an 1/8 inch. Now we have a good proportional tool. The next key here is to save this to our tool library. So the first thing I'm going to do before I forget is to give it a name, and we'll call this 0.020-taper-mill, and we'll tell it it's 15 degree. Then we'll come up here and set some of our requirements. We'll say its offset number is 10, its length offset is 10, its plunge rate is 6 inches a minute. Actually, let's say the feed rate is 6 and the plunge rate is 3. Now, of course, all of this has to be appropriate to your machine and your feeds and speeds, but I'm just setting it up for an example. Our retract rate would be 6, and we'll say it's 25% of what standard would be in a material. Okay, and before I do anything else here, I'm going to go back to the mill tab. I forgot to set the tool number, so we'll put a tool number of 10 in here, and we'll go back to the parameters tab. Now we're all set up, ready to go. Let's save it to a library. Now I can pick the library I want, so this tells me what library it will be saved to. If you want to create a custom library, for instance, you might have art mill tools, you would just come in here and type in art-mill tools, and that would save this tool into your library. I've already got one created, so I'll go up here to art mill tools inch and say save, and it saved that to the library. Now you might want to also add standard tools like I did here with a 1/8 inch flat and a spherical 1/4 inch. And you can just say select tool library and go to the mill inch tools. And I might want to add a 1/8 inch spherical. Once it's in there, I can right click on it and edit the tool, go to parameters, save to library, and say I want it in my art mill inch. And just to reiterate that again, we'll select tool, I'll pick another tool, so I'll have both 1/4 and 1/8 inch flat and spherical. So there's my flat, and I'll get a 1/4 inch flat in there. Once it's in my list, I right click on it, edit tool, parameters, save to library. Successfully updated. OK. Now I have both flat and spherical 1/8 and 1/4 inch mills to do my roughing with, and I have a nice taper mill of 20 thousandths to do my finish work in. So we'll select our taper mill and just do a finish pass. And I'll use the first cutting method, optimize parallel horizontal. To do a finish pass, usually would set your percentage to 10% of a ball end mill. Gives you a pretty smooth cut. I'll go from inside out. Filter, I'll take the pre-filter off, which will actually give me an even smoother finish. And we'll say generate. Now the toolpath is being generated. Once your toolpath is generated, you can look at it, or by hitting Alt-T you can toggle it on and off. You can also, in the in the toolpath manager or operations manager, you can click on the backplot icon and you can actually watch a tool cut through the part. You may also select solid model verification. And either watch the tool work through the part. We'll pause that. Or pick turbo, and it will go generate the whole part and then show you the finished part. Now we see the finished part, and by using our tapered mill we get very high detail of the art model. We can see it's also very smooth. This concludes ArtX Video Toolpaths Part 1. Welcome to ArtX Video Toolpaths Part 2. We will begin where we left off from Part 1. We have a toolpath here on our model. Now I'm going to go through and I'm going to select parameters here just to modify this one. We're going to go through the various toolpaths and talk about what they do and what the parameters are for them. Optimize parallel horizontal, if selected, shows just finishing, so you do not have the option of roughing and finishing with optimized parallel. You can just finish. The way optimized parallel works is it makes a horizontal path, and it will, if you say inside out, it will take a cut across the middle of your part, and then it will wrap it up, move over, and cut back on the other side, wrap it up, move over, cut forward on that. So it continually climb mills through the part in a parallel horizontal fashion. Your controls are step over, which is how much your cutter moves over each pass. These two are linked, so this is a percentage, and this will actually tell you the physical amount that it is moving, and that is dependent on your cutter tip. You can make the path go from the outside of the model to the inside, or from the inside of the model to the outside. Something to keep in mind is when you're doing a finish pass and you work from the outside of the model to the center, in softer materials it's possible that that very last pillar that it cuts could tear out, leaving you a nick in your model. So if using softer materials, inside out would probably be your best choice. Now, tool containment not supported means that you cannot contain your tool path within specific geometry. You have to cut the entire art-based surface. Toolpath containment is supported by the last three up to boundary toolpaths. So parallel up to boundary, parallel spiral up to boundary, hybrid parallel up to boundary. And that will be covered in the third of the toolpath videos. Depth cuts. If we go in here, we can take multiple depth cuts. If I check this on and pick the control, it tells us right now that we're taking 4 depth cuts at 420% of the cutter. Now remember, we've used a tapered end mill with a 20 thousandths end mill, so that's why this number is so high. So our depth cut's 0.08. If I wanted to say, the deepest that I would want to cut might be 0.04. If I click into another field, everything gets updated. But for a finish pass, I normally wouldn't do depth cuts. Now let's talk about filtering. If I click on the filter, we can have a pre-filter which will sort the points before the actual filter gets there, and that can make the actual toolpath processing happen faster. The pre-filter should always be less than or a higher tolerance than your cut tolerance. So if this is at 0.001 or 1 thou, this should be at 0.0005. Make sure that it's significantly smaller than your cut tolerance. Let's leave that off for now. If we go to the Advanced tab, we have some options here. We can have a plunge angle, which means as the cutter is plunging down in the material, it can go straight, which would be 90 degrees, or we could make it ramp down if we made a selection, say 45. This would put less stress on the cutter if it was going deep. Retract top height would be appropriate if you had a model that was all negative. So this would not cut the flat surface of the top of the model. It would just cut what was negative in your model. Accelerate roughing calculation helps the model to process faster. Smooth toolpath will actually double the resolution of your model, so that if you brought in a model of low resolution, it will automatically double the resolution so you get a nice crisp machined part. If you're making extremely large parts, it might make sense to set the resolution you want before you come to toolpath and then turn this off. So that's optimize parallel horizontal. The next one in sequence is optimize rectangle spiral. Optimize rectangle spiral is probably one of the best roughing routines that you can use for an art toolpath. And if we look down here, only roughing is shown. So if I wanted to rough this model, I would select a stock to leave here, let's say 20 thousandths. So as I'm roughing this with this tool, when I'm roughing, I know I'm coming back with a finish tool. So when I say roughing and stock to leave, it means it will leave 20 thousandths of material from the finished surface up. So that's what I'll be cutting with my second operation, doing the finish tool. I would probably use depth cuts here, and so I would say I would want just maybe 3 depth cuts. And if I was doing roughing, I would probably also use a different cutter. I wouldn't use my taper mill. I'd use my 1/8 inch spherical, and I would set my walkover to around 50%. And now my depth cuts might look a little bit more appropriate here, going down. Probably 50% of your cutter for roughing makes more sense. There we go. All that looks good. And our filter we could actually even open up, so I could say 0.005 here. This will make the toolpath file size smaller. Approach, what approach does is actually first thing it will do is cut a trough around the outside edge before it completes the toolpath. And depending on your application, you may or may not want to do that. And then you can also have number of passes there. We won't use an approach. So we're all ready to go here, and we'll say generate it. And since I modified this toolpath, I have to say regenerate. And we can see that our roughing passes have been generated. If we go into solid model verification, we can actually see the roughing routine as it works through the model, taking each layer at a time. Now I'll run through a number of the toolpaths relatively quickly, just highlighting the unique controls for that toolpath. Ellipse up to edge will actually, if you say from inside out, will start at the center and do an elliptical toolpath out to the edge of your art-based surface. The unique control here is spiral resolution, so you can make this spiral actually smoother or more jagged or faceted. Here is a quick look of the toolpath and of the verification. I have left the cutter walkover quite large so you can see the toolpath. Here is ellipse up to corner. You can see that the toolpath now goes all the way to the corner. And we'll look at the verification. Parallel horizontal does exactly that. It cuts a horizontal toolpath and walks over in a parallel fashion. You can do that one way and wrap it over, or zigzag by this control. Here's the toolpath. Here is an example of parallel vertical. It just creates the toolpath in a vertical manner. Parallel at a given angle allows you to do a parallel zigzag or one-way pass at any machining angle. These Guicons actually set up standards like 45 degrees, 90, 135. Here the toolpath is generated at 45 degrees. Radial up to edge will work the tool from the center of the part out to the edge and then back to center in a sun ray pattern. Here's a look of the radial toolpath up to edge. And the verification. Radial up to corner would go to the corners of the art base surface. Rectangle spiral rounded corners would do a rectangle spiral, but it would have radiuses on the corner. That is controlled by this parameter. Here is a look at that toolpath and verification. Rectangle spiral is a true spiral without control of radius on the corners. Here's a look at that toolpath and the verification. This concludes Art Toolpaths Part 2 video. Parallel up to boundary, parallel spiral up to boundary, hybrid up to boundary, and cylinder milling spiral will be covered on separate videos. Welcome to ArtX Video Toolpath Part 3. In this video we will show you how to use up to boundary toolpaths. If we look at our model here, I've added a inside square and then highlighted added the boundary that goes around the Celtic knot that we use to puff up the dome. Let's go to isometric view here. We can see that too. So there are often situations where you want to contain your toolpath, maybe for your roughing tool, maybe your part is clamped up and the sides are down inside a vise, so you don't really want to machine all the way to the edge. My toolpaths, I've already started an operation here, so I can just edit it. So let's do a parallel up to boundary. And when you're doing the up to boundary toolpaths, you need to select a containment boundary. So I clicked in the box to select a containment boundary, and I'll contain my toolpath. I will select the circle to contain the toolpath too. Accept that. And we'll just keep all our parameters here. Parallel up to boundary. And generate the toolpath. Now we can see that the toolpath is just within the containment boundary. Look at that in the top view. You'll also need to know that the toolpath is contained to the tip or the center of the cutter. So the cutter would actually be, cutter tip or center would end right here. If you want the cutter to flow onto the flat surface, you would have offset this containment boundary and picked that. Now containment boundaries can also be nested. So I can go back into my parameters, and if I want to add or adjust containment boundaries, I go to the second tab and say Tool Containment, Center, Select, and here's my chain manager, and I can either add or delete. Most of the time you'd probably come in and say rechain all, and so I'll pick the outer boundary and this boundary. So the circle is nested within the square, so the toolpath will happen between the circle and the square. And we'll regenerate that. Now we can see that the toolpath is between the circle and the square. We'll look at that from a top view. So you may want to, say, rough with a large tool. You could rough between these two boundaries and then come back and do your finish path just on your artwork. Other up to boundary or containment boundary toolpaths include parallel spiral up to boundary. So we can see parallel spiral actually does a spiral, walks over, does another spiral in a parallel fashion. So each one of the concentric circles is parallel to the other. It's not a true spiral. Our next toolpath, hybrid parallel up to boundary, actually combines two up to boundary paths, toolpaths. it will cut the part with a parallel motion, and then when that's finished, it will cut the boundary with a couple of paths to trim it up, because in the parallel motion you may have scallops on the edges, but the secondary paths would pick those up. We have some different controls here over on the side, part versus cutter. You would change this to make a better toolpath. You might want to examine your path after you generate this. If you have some very highly complex nested chains, by increasing this slider, if you have gaps in your toolpath, this will complete that. But always start with normal. Take a look at your toolpath, and if you like it, or you can actually check it with verification. If you like it, you're fine. If there are some gaps that aren't being cut by the tool, then by increasing the slider, it will help it. What this is doing is this is sampling every 50 points in your model, every 100, and there's actually little hints here to tell you what to use these for. If you just hold over it, you'll see it. So this is pitching out every 50th point. This pitches out every 100th point. Then the very last one is actually toolpathing every point on your model. But normal works pretty good. Let's get off this one and get that warning. Okay. Click back up here. Yeah. What it was giving you is on the exact, the 99,999, is that this would generate an extremely large NC toolpath. So everything's good here. We'll say go. And we can see here on the toolpath that we have a parallel toolpath with the cutter coming around and trimming up the edge. Let's verify this so you can see the exact process. So it finishes and runs a path around the edge to clean up the edge. In our second application for up to boundary toolpaths, we will use a sign. For instance, we had this sign, a very large sign that had Art Rocks on it. Well, we would like to be able to cut the surface of the letters and then use Mastercam regular 2D toolpaths to relieve the background. Because if we used Art Toolpaths, we'd have to have such a small tool with such a small walkover to get the letter surfaces to come out. We would spend a tremendous amount of time just machining the background flat. Let's take a look at the surface we want to do here. So here we're looking at it. I have shaded it and set it down an 1/8 inch to give you a better representation of what we're looking for. So we can see that in the top view. Go to isometric view. Go back to the top view and turn on our geometry. So the first thing we'll do is use Mastercam Toolpaths to machine out or rough out the letters or the stock that has the flat bottom. We will select Mastercam Toolpaths, Pocket, take the default name, and we'll use a window, and we'll pull a window out around that inside square. Select everything on the inside, say go. Pick a 16th flat end mill. Pocket depth will be -0.125. And we'll just do a simple zigzag. Step over is 0.05. Excuse me, 50% is what we want there. And everything looks good. And we'll generate the toolpath. And we'll do a verification here to show you what we have. So we have pocketed 1/8 inch deep and remove the interiors as well. Now we can come back to Art Toolpaths and just machine the top of the letters. This is what we're trying to achieve, is the best efficiency, be able to cut this part out in the shortest amount of time. So now we'll select Art Toolpaths. Now we'll select Parallel up to Boundary. Our step over will be 10%, which will give us nice smooth letters. We'll set our filter to 0.001 or 1,000ths. And turn our pre-filter off. And then we'll select Tool Containment to pick our boundary. Do that with a window. And we'll pick all those boundaries, even the nested boundaries, like the inside of the O, the inside of the A here, which means that our tool will be contained within those. Up to Boundary has just machined the top of the letters. So now let's go into verification and take a look at this. Let's actually select both operations here. I'll hold my control key down and get the second operation and go to verification. And we'll say go. So here's our pocketing of our letters. And then the Art Toolpath will start working on the surface. And there is our finished project. Once again, we used a large flat end mill to pocket out the floor and avoid the letters as islands, a regular Mastercam toolpath. And then we came back and used an Art Toolpath just to shape the top of the letters, giving us the most efficient toolpath strategy possible. This concludes Toolpath, ArtX Toolpath video, Part 3.